All right, dudes and dudettes and little girls and what's going on, my friends? All right, here's what we are going to be doing today. We're going to be talking about the project that we're going to be building. I have a question really quick. At this point in the story, where are you folks at in the story? I'm just curious. You know, the islands at the end of the world story. Chapter 20. You can't just tell me chapters. I read this thing almost like a year ago already. Where are they in chapter 22, 23? They're going to Maui. Okay, so they're on Molokai, and they went to they met like this dude, right? They met like this priest or something like that, or a pastor. Yeah, a coney. And then they went over to Maui. Have they gotten to Maui yet? No. Okay, I won't spoil it beyond that. But she drank toilet water at that point, right? Yeah. Yeah. And don't worry, it was out of the back of the toilet, right? So we're doing good. So that's kind of where our science is going to be heading in. That's the direction our science is going to be going in. That was a long time ago. Yes, and I know I mentioned that already. I actually spoiled that thing a long time ago, right? Spoiler alert from like a couple weeks ago, and then we started doing this idea of contaminated water. And what we need to do at this point is, look, if you look in any kind of survival guide whatsoever, every single survival guide is going to eventually have this idea of a water filter. You need to build water. And the reason why, and we've covered this, right? Because water is so incredibly important. I don't know why my mouth is sucking today. Water is so incredibly important to human beings, and we've talked about the importance of it, right? We've talked about the human's body need for water. The human body's need for water. Blah, 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 blah. There we go. The human body's need for water. Does that make sense? All right. So, what we're going to do, and actually, Alex says take salt water and boil it for 20 minutes. Actually, Alex, I think what you'll get, my friend, is saltier water. Believe it or not. You're just going to get even worse water. You're going to get water worse than what you started off with it. Yeah, I know, it's crazy. And in fact, we'll talk a little bit about that. Okay, so here's what I wanted to kind of do. All right, fine. We'll talk about what Alex suggested, and here's what my thoughts are. If you take salt water, let me zoom out so I have some space to work here. Zoom out, then I'll make the file bigger. You ever go to the beach and you ever climb on the rocks and you see the rocks that have holes in them? Not holes, but little, like, I guess I would best describe them as bowls. You ever see like a rock and it's got a little bowl in it like that? Little puka. But it's not a full-on puka because it's that. Yeah. You ever see it's just kind of like a little bowl, and it's got like water in here, and sometimes there's fish in there, and it's really cool. But anyway, you ever see the ones that don't have water in it? And what happens is there's salt in there. There's like, and you can tell there's salt because it's all white. There's a white crust around there. All right. So what happened, what I would think, Alex, in your scenario, where you're taking salt water and boiling it and saying, I'm making purified water. No, all you're doing is you're taking the fresh, pure water and evaporating, and that thing evaporates out. Like that. So what's left over, my friend? In fact, if I were to boil it for 2 hours instead of 20 minutes, it would evaporate all of the water out, or maybe, 3 hours, or however many. you're not adding salt, but what you're doing is you're leaving all that salt behind because the salt doesn't evaporate. So you have all of this salt in here. And it's the same amount of salt. You're just diluting it in less water. So therefore, Alex, I would not recommend boiling salt water and then drinking it to think that that's actually purified water. I hate to say it, my friend, but your boiled water will actually probably make you even more sick because you're drinking more salty water. So that's not it. All right. So anyway, here's a recap of what we're going to be doing, and then I'm going to get into it real quick, and then we'll finish class, and we'll have a lab, and let's talk about how to purify it, Mr. Parsons. But first, I want to kind of go over my answers with the Fruitvale thing. And someone asked for help, and here's my help that I'm giving you. I hate to say it, but I think I'm just giving you the answers at this point. But anyway, here's what we did. Here's what I did. Was I took the samples that we made, and let me look for it right here. There we go. There, this will be good. The strips. I took the samples. This is from the lab we did the other day, and I took all the wells that we did, and I took all of the samples that you folks made. You know, these little test strips, and I cut them off. I cut off the tips, and then I glued them onto, or taped them onto the map. And so here's basically what we did. And so one way that we did it, and this was your lab 2 weeks ago that you did, was you one way that we did was 2 weeks ago. You guys were able to put in your you guys were able to read the little sample wells, but we also had the little test strips, and that's what I used those test strips for. The question, or the things that we're having trouble with is that these little test strips didn't come out as accurate as I wanted them to be. And so that's why I'm making you folks do the quiz, where you folks are actually watching the YouTube video that we created, and then pausing the YouTube video, and then reading off each thing and understanding the code that comes out, and then putting that information into your sample things. So if you need help on the quiz, let me just kind of go over what that quiz is all about, which is, it's not hard at all. In fact, it looks like everyone who took it pretty much got close to a 41, if not... everyone who took it at least got like a 30-something. So it's like they can kind of understand. All right. Let's see. This would be the one you're talking about today, right? The Fruitvale testing. This is the quiz that you guys are having trouble with, per se. All right, so all you're going to do is you're going to watch this video, and you'll be pausing this video often. You'll be starting it, stopping it, starting it, stopping it, pausing it, and rewinding it, and all that kind of stuff. And then you basically, I go through with each of the groups, and I ask them, okay, tell me which one, what color this thing is. And so you look at the color, and so like this one's, I don't know, light green, or maybe that one's blue, or something like that. And then you say, okay, well, what does that correspond to over here? Maybe a blue-green. So I'm going to give it a code of 4. So whichever well that is, let's say it's well number 3. You go over here, and which code would you prescribe to well number 3? Well, we would prescribe a code of 4. And I don't know. I don't know if that's the correct answer or anything, but I'm just showing you guys what... What do you mean the video doesn't help much? How do you upload the website at the time? Wait, hold on. What website? What website are you guys talking about? Yeah, the video holds all the answers. I'm not sure what Jonathan is talking about with what website. I don't want you to print up any website. I don't know what you're talking about. Oh, okay, let's see. Huh. Is that the problem? Is it's not loading, or maybe it's taking a long time to load? Yeah, all this is it's the map. It's actually this map right here. That's all it is. I just want you to know where the wells are located. Does that make sense? In fact, I'm realizing that I'm looking at the wrong map, that I want to look at a different one. I want to look at, let's see, trivial answers, is this it? No, that's not it. I want to look at this one right here. Let's download that. Okay, save the file. I'm going to try to drag that into there, and we'll see what happens. Let's see. All right, because what we're going to do is we're going to take the answers that we got, that you guys were able to come up with. All right, here we go. So, I hate to do this to you. Yeah, the video, no, it's not important to print the map. You don't need the map to do the assignment at all. Yeah, there we go. Okay, so check this out. Here's all the answers. These are the numbers that you should put in. Yeah, all right, I know. Which is why I want you to do it by today, because I'm going to basically be giving you the answers. But I realized that I needed to cover this inside of our topic. All right. Yeah. If you already did it, you can redo it, and if you want to, redo it, and then basically maybe this is your gift for showing up today for class. But here's kind of the reason why I'm showing you this is because, all right, it looks to me like well number 8 had a code of 5. All right. And so what I'm going to do is I'm going to draw a circle, or maybe a boundary, that includes... Wait, what are you talking about? I'm mad. I'm not mad. I don't know what you guys are talking about. Anyway, I'm going to draw a boundary around this that includes all of the level 3 wells. Because the level 3 wells are the contaminated wells. So here's my contamination area. I draw a boundary around all the level 3 wells. You guys got it? I'll draw a little circle around here. All right. Oh, wait a second, Isabella. No, the video does tell you which wells they are. I go through. No, I go through it, and I take. I point at each one and say, "This is well 1, 2, 3, 4, 5." I actually, yeah. No. What you need to do is I tell you which well it is, and then you need to look at the color of that well, and then decide what the thing is, what the code is. But here's the secret between you and me, Isabella, is I'm literally giving you the answers right here. So what I did was I drew a little circle around all of the well number 3s, or all of the wells that have level 3 contamination. Now I'm going to draw another circle. We'll make it orange. Around all of the wells, or let's make it a purple. Around all the wells that have a contamination level of 4 or higher. So here, okay, wait. So let's see. Around here, around here. So it kind of looks like this. All right, and then we'll make sure I also circle this guy right here, which this one is Seamus's favorite one right here. Because it looks to me like the highest amount of contamination is where? At the trash site. Exactly. There we go. And this is the thing that Seamus was like, dude, it's the trash. It's totally the trash. That's the one it is. It's the trash. And I'm just like, okay, all right, dude, we're going to do some investigating. And then it turns out that he was right the whole time. So well number 8 has a code of 5, which basically means that it has, what was the code of 5? It has more than 32 parts per billion. That's a problem. Because anytime you have more than 1 part per billion, then you have a contaminated well. That well is not safe enough to drink. So what I wanted you to notice here is that the contamination kind of started off here, right? That's the heavy duty stuff. And then it kind of, a lighter level kind of spread out like this. And then an even lighter level spread out like this. Kind of like that. Do you guys know do you guys see what I'm saying here? So what's happening is we're creating these things that we call plumes. And these plumes are spreading, and these plumes are spreading in a lower concentration as you get further away from the source. And so that's kind of that is exactly the thing that we want to discover or talk about today. And we want to talk about point source plumes versus or the different kinds of contamination plumes that we would be dealing with. So let me show you some of the different plumes. I don't know if I want to bring this thing up on a website, but I just want to do this one. Here we go. All right, so here's a contamination plume. And so maybe this part right here is really heavy-duty stuff. And then as you get further out, it becomes less and less dilution. The dilution is less and less. Does that make sense? Yeah, we finished around that. But I want to make sure you get through this stuff with you. So this is a plume in 1984, and then in 1988, here's what the plumes look like. And what is this telling you? What is this information telling you? That the worst pollution, that it's getting bigger. Exactly, absolutely right. That this thing is spreading. That the contaminated area was only in here, and then it grew out to over here. That's a problem. By the way, just looking at this plume, why do you think there might have been, like, this plume doesn't grow over here? I'm just by looking at the plumes, can you give me an idea of what might happen? Because of a fence. Okay, maybe a fence. Or what if this? What if this were an island or a hill or something like that? Or maybe this is a family over here and they dug a moat around here, or a rock. There we go. Yeah, maybe it's a tall rock where the contamination couldn't really go up the rock, so it kind of just went around it. Which makes me kind of come back to this idea right here. And I want to look at this dry creek bed right here. I want you guys to examine this thing right here. This dry creek bed floods during storms. So, What? It has a contamination level of 1, whereas everything around it has a contamination of either 4 or 3. What do you think happened? We'll talk about our experiment. It got polluted. No. It has a contamination level of 1, which is safe drinking water. But it's surrounded by contamination levels of 4, 4, 3. So what's the deal there? What happened there? Don't talk to me about breakfast. Talk to me about this science stuff. There's something in the way. I like it, Quinn. Okay. All right. What else? What else? What could be some ideas? Maybe it's the furthest. No. The contamination area is right here, so it's pretty close to the thing. There's a drainage system. Okay. All right. Here's my suggestion. I agree with Quinn's idea. I think Quinn is kind of getting at maybe there's something that is filtering the well, or maybe there is a high, maybe this area right here is like kind of on a sloped area, where the contamination doesn't crawl up or something like that. To me, that doesn't make as much sense because they describe it as a dry creek bed. And it floods during storms, so it means that water gets to it. So here's what I think. I think we just screwed up. That's what I think it is. I think that we measured it, and maybe by experimental error, we accidentally switched that beacon or something like that. Yeah, because the evidence shows that around it there's a level 3, there's a level 4, there's a level 4. I'm thinking that area should be a 3 or a 4. So what I would do if I were running this experiment is I would send out those people again and say, all right, or I would go out there myself and I would say, let's look at this area specifically, because in this area, either I'm going to find a big rock where this contamination can't grow up, or I'm going to find a, or I'm going to find, like a hill or something like that, or I just screwed up my experiment. Does that make sense? Awesome. Okay, so here's what we're going to do. We're kind of going back in the same lines of water contamination and filtration, all of that kind of stuff. Let's talk real quickly about our lab that we're going to want to run on Wednesday. And here I'm going to introduce to you guys the project that we're going to be doing. And so I'd like for you guys to bring in the materials. I'm going to write up the lab and send it out tomorrow. But I do want you to bring in the materials because I want to talk about what we're going to do. What we're going to do is we're going to do a really awesome project. It's going to be a water filtration. We're going to be building a water. Yeah, so what did Miss Waterhouse say about what we're going to be doing? All right, we're going to be building a water filtration device. And then what we're going to do is we're going to build it and make a competition out of it. We're going to try to figure out the best way to build a water filtration device, and we're going to compete against each other to try to see who can build the best one. And so I'm going to break you up into your teams, your Ohana groups or whatever they're called, and we're going to try to experiment with it to see who can filter out the most amount of stuff. I'm not going to set it up so that way you guys will be drinking the water. I don't think that's a good idea. But let me talk about some filtration ideas and the way water is filtered. And then we'll talk about what we're going to be building. And then so after this, almost the rest of the class, we're going to be talking about ways to test how good water is. We're going to talk about the nitrogen cycle that goes through our, that is in our Earth system. We're going to be talking about different ways to build these things, and we're going to be working on this project. So that's pretty much what's going to take us to the end of this quarter. So what is inside water that could be dangerous to us? And we talked about this in great detail. Bacteria, protozoa, microscopic parasites. There's chemicals in water, from household things to factories putting chemicals in water, nutrients, poop. That's right, I said it, poop. Yeah. Okay. So here's what we're going to try. Here's one of the types of filters that we could build. This one's called a biofilter. It works the same way that sewage treatment plants does, and it uses a multi-stage approach. Here's the simplest kind of water filter that you could build. Say that you're stuck out in the woods, or maybe, you know what, this is actually, see, I feel like I'm really excited about this because this feels very relevant to what we're doing, because we've got all these storms heading our way. And so what I did over the weekend was I stocked up on water. I made sure that my family has 45 gallons of water that I need. And I put that all underneath my dining table. And then I made sure that we had like canned goods and that kind of stuff. But I have 45 gallons of water and I have 5 people, I think. Because the way that you calculated it out is like each person needs to drink 1 gallon of water a day, and I want to have enough water to feed all of my family of 5 people for a whole week. So actually, I think I'm supposed to get more than that, but no, I'm about good. 35. I need 35 gallons of water, so I have a lot of water that I need, and that's water that I use. And so maybe this is very relevant to us because what happens when all of that water runs out? What happens if we are out of water for more than a week? Well, we're going to need to figure out a way to filter our water. See what I mean? And I wouldn't recommend putting salty water inside of a pot and boiling it. That's just going to make you more thirsty. All right. The first simplest way, and I wouldn't recommend doing it, but maybe you could, is just use a cloth filter. If you're stuck out in the middle of nowhere and you don't have anything, you take a piece of your shirt or something like that and you put it over a jar and then you pour the water through and voila, you have made some kind of filter. Dude, don't be so negative. We're not going to die yet. All right. Not necessarily the best idea. One of the things I would do, and this is kind of an idea, and I'm not telling you exactly how you need to build your filter, but I'm just giving you some ideas. One of these things is I would make these a layered filter. And what you could use is you could use gravel and sand and activated charcoal. Now, what makes charcoal activated? Activated charcoal, all right, activated charcoal is made by blowing air through it. And basically what you're doing is you're freeing up the little pores that are stuck inside of that is inside of this charcoal. So you can kind of think of this charcoal as a hard version of a sponge. Now sponges have a lot of pukas inside of it, as you folks love saying. It's kind of like your face. And I say your face specifically because I'm talking to a bunch of, I don't know, how old are you, like 12-year-olds? 11-year-olds? Okay, so maybe not your face per se, but maybe the face of your older brother and sister who have lots of pores inside of their things, and a lot of those pores are clogged pores, so they have unactivated faces. But if you were to pop all of those pimples that they have, then that would be clearing out all of those little pukas that they have, and so they have a lot of pores inside of their face now, and those are a lot of open pores, and so basically they can have an activated face. Yeah, I went there. So here's the crazy thing, all right? Which has more surface area? A block of wood or a sponge? They're about the same size. Let's make them the same size. But a block of wood versus a sponge. Which one has more surface area? What I mean is by that is which one has more of the outside touching the air? The sponge, exactly, because you have all of these little, like, here, let's get some more space so we can start messing with this thing. Very good, the sponge, because you have all of these little pukas. So like here's a block of wood, and here's a sponge with all the pukas inside over here. So my question is, which one has more surface area? And the surface area, it would take, it's kind of like if I were to paint this thing, which one would require more paint? Well, the sponge would require more paint, because if I were to paint just the top over here, I would just paint it like that. But if I were to paint the sponge, I would have to paint over here, and then all of this area, and then all of this area, and then this puka over here, and this puka over here, and this puka over here, and all of that kind of stuff. That's kind of what's going on. Does that make sense to you? The sponge is very porous. It has a lot of pores. Well, activated charcoal also has a lot of pores. In fact, it has so much pores that now let me make sure I get this data correct, or make sure I get this correct. 1 gram of activated charcoal has over 500 square meters of surface area. That is a huge amount of surface area. So what's happening is it's basically trapping in all of these small little particulates and whatnot. So when you pour water through gravel, that traps all the big stuff, like the bugs and the insects that are growing inside that water, and also the leaves that maybe you didn't do anything about, or the small pieces of dirt, that kind of stuff. Then it goes through the sand, which removes the smaller particulates of matter. And then it goes through the charcoal, which has so much surface area that thing kind of the water has to go through it and it scrubs all of that stuff down really well. All right. So here's how I would build it. I'd take a water bottle. I'd cut the water bottle off. I'd poke a hole inside of the cap of the water bottle using a knife with adult supervision. Then what I would do is I would put at the very bottom some coffee filters, probably to kind of catch the last bit of stuff. I'd take my activated charcoal, which is made by burning wood, and I would crush it up into smaller pieces, and I would put it inside. Then I would probably put in a layer of sand. And I would, you know what I would do? Just for good measure, I would put another layer of charcoal and another layer of sand. And then I would probably put a cloth on top to filter out the really big stuff. And then I would boil it. Because even if you have filtered water, you'll want to boil your water after that. Does that make sense? Yeah, and I'm not recommending that you folks... Wouldn't the water get charcoaly? Yes, it would, and you're using the coffee filter to kind of filter out that blackness of the charcoal and whatnot, but it's still kind of clean. Now, I mean, talking about this as an emergency backup system, this is not obviously what you would do every single day. I mean, maybe you could if you folks want to be completely off the grid or something like that. But this is not the way you would live every day. This is what we would do in an emergency situation, and lay in the book is in an emergency situation, and also that kind of stuff. I'm already off the grid. Yeah. All right. Gosh, man, I feel like I have such a good lecture prepared for you guys, and I keep running out of time. I'll tell you what. Yes, you're absolutely right. We need to finish class because I told you folks that I would, and let me just tell you about the filter that we need to build. I want you guys on Wednesday. You guys are going to come in, and we're going to break up into our teams and start building the filter. I'm going to try to get as much materials for you as I can, but I want you folks to bring in stuff like small buckets and that kind of stuff. I'm trying to bring in. I'm trying to get Zippies to donate for me a bunch of those small, like the benefit chili containers. the small little buckets. I don't want you guys building a filter that requires 3 5-gallon buckets stacked on top of each other. That's kind of overkill. Maybe you could build it layered in 1 5-gallon bucket, and I'd be fine with that. But 3 on top of each other, I don't want you folks lugging that thing around. And then what we're going to do is we're going to probably build our filter system with the same idea, but instead we're going to keep the sand and the charcoal and all of that kind of stuff separate into different jars right here, or different buckets. So that's what we're going to be building. I'm going to be sending out for you tomorrow a list of materials that I want you to try to bring in. For the neighbor island students, don't worry, you folks are going to be working with another team, and we are going to be having our water fest, or I think it was a filter fest. I forgot what they called it, something fest at the end of this year. And we're going to be working on, we're going to fly in the neighbor island students. You folks can come in and we will compete. And for the neighbor island students, we're going to be, I think that what I want you to do is we're using all of the stuff we're building is going to be not stuff that is, or stuff that you can get on your own, and it's not stuff that like we have to order specially just for you. And anything we have to order, I'll send to you. You'll be able to build one of these on your own. Okay? So expect something from me at the end of the day today, or maybe tomorrow, and you'll be able to do that. And I can't say this for sure, but I believe that this is going to be reimbursed for, your flight will be reimbursed if you buy the ticket. And I don't think that we're going to reimburse you for first class tickets. But that is not something that's my call. That's something through that's a call through somebody else. Quinn is asking, does the thing need to be automatic? And here's what my answer is. I would like to add that component to our class, where I bought these windmill things that we can use to have the water be transported from the bottom to the top of the filter. Because if you think about it, if you're setting up this filter that you want to have used every day, it'd be a pain in the butt every morning to go out and get all these buckets of water and put it at the top and then wait for it all to come down. So what I'd like to do is build a windmill that will basically pull the water up to the top and have it automatically done for you, wind powered. Now, whether or not we'll be able to do that for this particular project right now, and we won't finish it in Q1. I don't know if it finishes in Q1. Or maybe what we do is we add that as an extension onto our project later on. So for Q2, we do that part of the thing. What OS do I have? The OS of, I have no idea. I have the newest MacBook Air that they gave me. And also, this computer that I'm doing the screen share from, that is actually a Windows. And it's like Windows 2007 or something like that. Something old and dumb. All right. All right. Questions, comments, concerns, vomits, and etc. Okay. All right, I'll talk to you later. Okay, bye. Wait, somebody asked if school was extended or if you're getting an extension, time extension. What are you talking about? I think that was Titus. Who asked about a time extension? Oh, Alex, what did you need? A time extension? To extend the class and make it longer. You want this class to go longer? I'll tell you what. I asked for a time to push back the time. But as far as the time extension, I think that it's good that we go for about 40 minutes on Mondays and then an hour on, or like an hour and a half on Wednesdays. That's good. But if you can't get enough of me, if you like really want to hang out with me more, you can always just re-watch the archives. All right, I'll talk to you later. Hey, bye.